But just briefly, my work is really about light. It's all about understanding the phenomenology of light, primarily daylight, but also artificial light. And I became involved in working with light as a medium basically in the late 1960s when I was in school. And that basically led me into glass as a material to capture and manifest and sort of explore qualities of light and information, basically, that the content of light in the work that I did. So a lot of the work, I'm just starting to show you a few projects which in the late 60s and 70s were really film projects that explored a phenomenon of light and how you might capture a phenomenon that you would see in nature, synthesize it, and establish it as something you would experience in an urban environment. How you sort of connect people, as Richard was saying, how you connect people to a very richness of urban life where nature exists around us, but we tend to not observe it or see it. So my work really goes very much in the direction of having people understand the richness of an urban context and what architecture can do to explore that, amplify it, and sort of sustain a different sense of our lives within an urban environment. As Martha was saying, I've also sort of parallel with this work that I do as an architect and previously sort of an artist. I do a lot of work for Corning Glass Works, which is a very large technical glass company, which you may be aware of. And I started working for them in the 1970s on a lot of photosensitive glasses, glasses that respond to different wavelengths of light. And I've continued to work with them today, and we're currently working on a lot of glasses, which I'll talk about later, but all of these glasses today, which are used for all of our cell phones and computers, extremely thin glasses, literally thinner glasses now that are much thinner than this piece of paper and are hundreds of times stronger than the glass we're familiar with. And they're currently glasses that you can roll up. You can roll up. The glass comes in a big roll, almost like fabric. So one of the big things we're working on today are means of transforming construction utilizing thin film glasses, which deals with weight and quantity of glass necessary to enclose buildings and the structure of thin film structures, all these different aspects of glass that you couldn't necessarily explore in conventional types of glasses. But I'll talk about that a little bit. But I'll introduce you to my own work and how it has basically, I guess, sort of morphed over the years from work done in the early 1970s. I'm just going to touch on one or two of these to give you a sense of where I come from conceptually in work. But I basically studied chemistry and had a great interest in biology and chemistry together. So a lot of the films deal with events you see in nature, and this happened to be a small river in Puget Sound. This is done 35 years ago, almost 40 years ago. A small river in Puget Sound where a friend of mine was doing his PhD work, and they managed different genetic strains of salmon. They'd release them into the river, and then they obviously come back. And the idea here was that over the river, you'd build scaffolding over the river and then a series of cameras that would look down into the surface of the river. And then you would take that series of films and then you would project them basically in a museum or in a gallery. So you walk into the museum, and basically on the floor are fragments of that river with the fish. As you can sort of see here, salmon moves through one film frame, through darkness, into the next film frame, next film frame. So you have this sequential capture of migration, basically the notion of migration sort of moving through the museum. And what interests me, I guess, about these phenomenon and when you observe them is that the content of things we look at is much broader than we acknowledge. Our eye tends to narrow down to very familiar things and basically sort of discounts a lot of information that's around us. So I'm very interested in how we recapture the wealth of content that exists in the world around us and bring your attention to those specific things. So this is just a little way of sort of demonstrating what this project was about. The river, the movement of the fish over the river, but by shooting the film and then you change the timing of the film slightly. Instead of running the film at the conventional speed, you print the images so they repeat each other and they hold themselves a little bit longer. What you begin to realize that the image isn't necessarily just looking through the surface of the water and seeing the fish. But if you change the timing, that same film image all of a sudden reveals the fact that you're looking at an absolutely perfect image of the sky reflected in the surface. So it's really taking the surface of water and the information that's seen through the water, the information that exists on the surface of the water, and the information that's reflected off the surface of the water. So I oftentimes use this idea of water as a corollary to glass, that glass is a material that has content reflected on its surface, content within it, and content through it. So the material has a capacity to inform us in a much richer way than we tend to acknowledge. And this is a project done about 10 years later for a family in California that had a very extensive art collection, and there's a small river on their property, and they had a bridge that would lead you over this small river, and then they commissioned me to do this bridge for them. And the idea here is that you cross out onto this glass platform, then you move along this glass platform to the other shore of the river. So that moment in time when you're crossing the river isn't necessarily just going from side to side, but extends your experience of that particular ecology or environment. So this glass platform is really suspended over the surface of the river. The idea is that the light comes down, hits the river, reflects back up. So the glass platform, which is translucent, carries with it the image of the water itself. So the idea here is how, and this is really sort of, I'll just show you one or two of these projects. This is sort of how I tried to move from doing work in the art world primarily, which is a very limited audience, to how you move out of that into the architectural world, which is where I originally studied. How do you build things permanently that can capture in a conceptual way sort of a richness of our environment? So the notion here is that you walk on this glass platform, you've basically extracted the surface of the water and made that the surface that you're walking on. And by just using slightly reflective panels of glass, they basically superimpose reflected images of the landscape around you. So the bridge actually sort of consolidates the landscape on the one hand, and that also sort of lifts this quality of the water below it. So it's a way of how do you create environments where all of a sudden you begin to understand these elements that are around you in a very different way, and you sort of build a new experience or a new environment. So other projects done about that same time, and this is perhaps a little more conventional, is a small project done for a client out in the Midwest. And this is the only desire on the client's part that he's built. This is a chapel. It's sort of a small chapel that's part of a seminary. And the only desire he had was to maintain totally clear views of the nature outside. So you'd sit in the building, look out at this very beautiful landscape and the trees. He would have been happy with that. But I wanted to try to figure out a way to do more than just have a clear glass window, but how you would sort of animate the space. So you're looking through the window, and the window is about 12 meters tall. It's quite a tall window. There's single pieces of glass that run the full height. And then there are these panels of glass, which are roughly that dimension, that stiffen these vertical pieces. So you look out at nature beyond, and there's sort of this overlay of another layer of glass in front of it. And basically what happens is sunlight comes in, a portion of the light is reflected, a portion of the light is transmitted, and you end up with this idea that the light basically occupies the space. It comes in and sort of dominates and takes over the space. And what's happening here is that as you have clouds in the sky, basically that image is brought in and projected on the wall. So you actually see clouds moving or birds. And then when the trees have, like in summer and fall, when you see those leaves moving, that image is projected down in. So in a way, it's connected to film. It's a bit cinematic in that sense, that it's bringing abstracted qualities of nature into the space, and you observe them in a very different way than you would otherwise. And of course, the dynamic of daylight is you'd walk in here sometimes, and it might not be anything on the wall, or there might be just very subtle pieces of this, or all of a sudden the whole image appears or it disappears. So there's this great sort of dynamic, and I think that that's fundamentally what interests me. There's a quality of animation that we lose, but we need to somehow reintroduce. And then secondarily is this concept, which is something you'll see in most all the work we do, is that the window is no longer a single piece of glass, but you've taken that idea of boundary condition between exterior environment and interior environment, you've expanded that boundary. So you have an interstitial zone that reinterprets the relationship between exterior environment and interior environment. It's no longer glass as a transparent material that's abstract. Basically, glass historically in the modernist movement has been an abstraction. There's no material. You are seamless with the outer environment. The outer environment, inner environment are seamlessly joined. And the glass as a material has no physical presence. So our work is really just the opposite. It's about how does the glass device or structure or material clearly define the differentiation between interior and exterior. Like there is a richness and differentiation. It's not the same. It's not the same interior as it is outside. So you have a way of doing that. So some of these projects are very simple. Again, this is not dissimilar to that chapel project. This is here on Columbus Avenue. It's downtown near Lincoln Center. It was just a wall on a building, a brick building, and the neighborhood or the community group was very upset about this new building that was built. And then we were ultimately sort of commissioned to come up with something that would change that quality that people would experience in a fairly dense, urban area, more residential area, instead of this large blank brick wall. So what you're looking at is a glass surface. It's actually a glass that's used on solar collectors. And then these are glass fins that extend off the surface perpendicularly. So you have a background glass and a glass fin that extends off the surface. And it's very static as a structure, of course. But if you look at it at any time of the day or any time of the year, it's completely different. Like this is the same moment in time. This is looking at it from one direction, and that's looking at it from another direction. So it's the idea of building what we would refer to as a responsive surface. It's a surface that responds to you, meaning your place, your position within that immediate urban context, and the position of the sun. So it's always that dynamic between where's the source of light and where are you in relation to it. So it's something different every time you look at it. And it also is designed to, this is critical in a city, it's obviously blocked many hours of the day. There's no light available to it in terms of direct light. So this is actually in an afternoon where the light is actually, the sun is beyond it, it's technically in shadow, but it picks up on different qualities of light and then it projects light down into the street. So oftentimes it'll animate the street. So you get these effects, which are, say, light coming off of a building that might be 4 or 5 blocks away. It's just a random piece of light that hits the surface. We see this all the time in the city, but it's normally, it hits a brick wall or it hits cement and it's not anything remarkable, but as soon as it hits a surface like this, all of a sudden it creates something very dynamic. And the idea of the wall here is, I guess, best exhibited there, which was this idea of the flat wall not having any sort of dimension to it and sort of suggesting that it's actually just this sheer surface. But as you can see, what happens, it looks like the fin, the idea of the fin was that the fin would go to the glass surface, then it appears as if it's extending back into some other space behind it. So the wall tends to set up this idea that there's occupied space or other space, dimensional space behind it. So these are just, these are just a few collection of small projects that demonstrate different ways of working with light. And then this is something down in Washington, D.C., done about 10 years ago. But it's a very good example of something that we're trying to get a better understanding of and execute projects more in a more informed way. This is a building built for a large sort of law firm, and the architects had designed a atrium space which had a skylight that's about 20 meters long and about 3 meters wide, and the space itself is about 50 meters tall. So very narrow slot, very deep space in the building with offices looking into it. Obviously, those dimensions effectively mean you're going to get light from 11:30 to 12:30, like in the noontime, you get a little bit of light coming in and that's it. So this is a device or structure that we built, which is made out of glass. There's a centerpiece of glass that's relatively narrow at the bottom. and then it goes up to about 3 meters in diameter at the top. So it's a glass cone inside of a fabric structure. And what we're doing here is on the roof is a heliostat, obviously a tracking mirror. It's not so large, you know, it's maybe, you know, the mirror is maybe this big, you know, not much bigger than maybe half of that window over there. The sun, it tracks the sun, sunlight, it then hits the secondary mirror, and then the secondary mirror drops the light down inside the cylinder. So what's happening is the glass, it's a special glass that has a particular prismatic surface on it. So we're dropping the light down into the cylinder over roughly 40 meters. And the light is falling at about 2-degree angle as it comes down. So the light hits the glass and it's refracted out. So you're taking the light and you're constantly over that full dimension, you're bending the light and projecting it out. And you see the light on the glass itself. You see the light on the fabric that's around it, and then you see the light that's passed through it, and you see it again on the wall. And the principle here, and this is just something that I think we all need to learn more about, is that if you think of that as just one small window, it's basically just maybe 2/3 the size of that one window. That's all the light we have, but you're actually then using it to illuminate a huge space. And it's only an example of saying that we don't know how to use the light. There's so much intensity in sunlight that your eye tends to close, and it creates very high contrast and all of that. So we're not really using that sunlight very well. But if you have a way of distributing it and having the light fall on multiple surfaces, all of a sudden the perception is that there's an enormous amount of light. So it's just a principle that we think is something we need to work on more aggressively on buildings. And this, of course, is at the very bottom of the space. And we were obviously not able to use all the light anyway. So that you're still getting, you know, very high amounts of light at the bottom that you haven't quite used. So just an example of like how daylight works. And then this is, I'm sure it's showing you a range of things just to maybe get you to think about light in a different way than you typically do. This is a project for the Olympics in Sydney, Australia. And the Olympics were all about reclaiming industrial landscapes, like an old oil refinery and steel yard right outside of Sydney on the harbor. And they wanted to reclaim that for the Olympic Park and turn it into a public park afterwards. So the whole project was about reclaiming toxic land, reclaiming water sources that had been contaminated, and all these things. And they wanted people to realize that what they'd gone through to reclaim this whole space. So we wanted to try to use this idea of water and water vapor in the sense that we know that the water's evaporating at the surface from bodies of water or even from the ground. That water's then going up into the air microscopically, condenses into clouds, and then obviously sort of comes back down. But creating a synthetic cloud, what we did here is this goes down into a tidal stream. Here's the main bridge. You enter the Olympic Park on this bridge. You go over this tidal stream. We're taking the water from the stream and filtering it and then pumping it up these masts, which you can see. I'll just show you the masts come across. They create a threshold that everybody walks through. So you're creating this cloud that sort of floats across here. And then there's another device in the distance there, which I'll explain to you in a moment, which is also a heliostat. And this is what we were trying to do. We're trying to create essentially like a mirage. Like how do you, in the middle of the day, under a bright blue sky, direct sun, how do you create forms in space so people sort of see it? So these were tests that we were doing. This is a little misting system, industrial misting system, a mirror, sunlight hitting the mirror and bouncing it back. How you get these broad beams of light just in the middle of the day appears in the sky. And it has a lot to do with filtration. I mean, if this is a regular mirror, you wouldn't see this because it's all full spectrum light. If you bounce back full spectrum light, your eye doesn't see it. But if you filter the light, we're letting all the blue light go through and we're only bouncing back yellow light. So your eye is very sensitive to yellow. And all of a sudden you see it. And we're taking that whole thing into effect. Here's the men sort of installing a couple of these masts. The top part of the mast, the top 5 meters is for the misting system. And then this is the mirror, which is about half a kilometer away up on its own mast. And what happens is this. Basically, the masts create this synthetic cloud overhead. Sun comes down, hits the mirror. A lot of the light's going through the mirror, but the yellow light is sort of being bounced back. So all of a sudden, overhead, you get these ribbons of light that sort of appear overhead. And it's obviously the first principle is simply that the light is always around us. The light is always there. Only when it hits a surface do you acknowledge it, right? So it's there. So it's all about the presence of light and the surface upon which it falls that makes it aware, makes you aware of it. So this is really all about weather conditions. Like occasionally it makes this sort of form. Sometimes they're like localized. Sometimes this beam of light will be 2 kilometers long. It's like a solid bar of light that goes for about 2 kilometers, and you just sort of see it in the sky overhead. So it's the same principle, obviously, that's happening back here, and the clouds beyond it. Sun's coming down. It's illuminating the top of the cloud. The cloud's so dense that the light can't get through, and therefore it appears to be dark underneath. So we're basically just taking that, instead of the sunlight coming down, we're sort of bringing it and projecting it horizontally, so you see it in a different way. And that's at sunset. It looks quite different at sunset. And then, so anyway, those are a range of things. We do a lot of those types of projects because they're great and fun, and sort of fun to explore them and do the development on them, and they let you look at different phenomena in a more experimental way. And then we do a lot of work on buildings all over the world. This is the Hearst headquarters here in New York, which is down here on 8th Avenue. The original building was built in 1928. New building was done with Foster, and we do a lot of work with Foster. I worked on his very first building, the Hong Kong and Shanghai Bank, many years ago. But we were asked to take that. This is the historic building facade here. This is a section through the building. You're looking at the historic facade on 8th Avenue, and then the beginning of the new tower behind it is how you bring people in through that original entry up to the new lobby. So we worked on establishing these large skylights in the space, and then primarily designed this element here, which is made out of glass. It's a glass wall. It's 3 stories high, and the escalators come up through it. But it's linked to sort of the management, the cooling systems of the building. We take the rainwater off the roof, we bring it down, it's stored below this surface, and it's chilled. The chilled water is sort of brought up and then run over the surface. So chilled waters, very cold waters, run over that surface, and it creates a whole convection current in the space, and the humidity basically condenses on that cold water surface. So you're using water as a dehumidification system and cooling system in the lobby. So on one hand, it's a cooling system. Secondarily, you're taking all this daylight, and much like a periscope, you're taking this bright light, bringing it down, and bouncing it out to the street. So when you're on the street, you look into the building. Instead of seeing a dark volume or dark lobby, it's a very bright surface, and it brings you in. So the way we just work with cast glass here, these are machined graphite molds and pouring the glass. These big castings, you know, they're maybe that long and that thick. They're basically prisms. And then those prisms are laid up into this wall system. And below this is the chilled water system underneath there. And then when you walk in, this is what you see. You sort of walk in. It's acting as a periscope. So by looking at that surface, you're actually looking at the light that's directly overhead. And then the water is running over that, cooling the space. But the water also serves the purpose of the population of this building is about 3,500 people. You know, so there's that many people coming and going. You have a very large dining area up on this upper floor. So at times you have big, high populations of people, then very few people. So the water flow is actually choreographed to the number of people. So you need greater cooling when there's greater numbers of people. You need the white noise to sort of cancel out the sound in the space at that same time. So it's always sort of this whole flowing surface next to you as you go up and down. So this is something that we do a lot of, and really try to seek out projects to do these types of things where it's combining sort of the maintenance issues of the building. Like, how do you cool the building? How do you change qualities of acoustics in the building? How do you do the light qualities of the building? How does something which, on the one hand, just is a very beautiful object or sculpture in itself, but how do you overlay on that something that's a little richer and more, you know, it's more of a giving opportunity within the building. And that's not dissimilar to this project, which I hope you may get down to see this today, but this is the 7 World Trade Center tower. This is the first building built down at the World Trade Center site. We began working on this in October, actually, just a month afterwards. It collapsed. The two big buildings that you're familiar with are behind it. They came down. You probably read about this building. When those big buildings came down around it, the original building here had a lot of diesel fuel storage in the building. It had the New York City Emergency Response Headquarters was in the building, and the FBI and the CIA. All of those agencies were in the building, and they had an enormous amount of fuel storage because they had offline generators, so they could just operate regardless of what else was happening. But the lower, and this is particularly of interest perhaps to you, the lower 6 floors of the building originally was a power substation. So the power coming into the city came into the substation, and then above the substation they had these big transfer trusses. So the buildings collapsed, the building came down, everybody got out of the building safely, but the diesel fuel in that original building caught on fire, eventually softened the trusses, and then the building collapsed on itself. So it was a much bigger building than the 2 towers, I mean, in terms of square footage. But the reason this building was built so quickly is that they had to get this power substation up and operational as quickly as possible, because all the power from the World Trade Center site and much of the power for downtown Manhattan came through this building. So this is many years later. This is like 2004, after all the excavation work and the new foundations coming up. This is basically the power substation. So the lower 8 floors of the building is basically a solid concrete box, and it has 5 big transformers on the north side and 5 on the south side. And the lobby is basically shoehorned between the substation. And these are big transformers. These are, almost 30 meters tall. These are like, they come in by boat, they come in by barge, and they're put in here. So we were involved. We got hired by the owner very early. The architects were Skidmore, but we were charged with the development of the whole exterior of the building. So the first order of business was, okay, you have a concrete power substation in the center of downtown Manhattan. That whole part of the city is going to change. It's going to be more of a cultural center. It's going to be a more active pedestrian environment than it used to be. So this building had to be something better than what you would conventionally think our Con Edison friends would provide. So we were hired both by the building developer and by the power company to develop the whole exterior of the building. So this part of the building, which is where the transformers are, had to be 50% open for natural ventilation. And then we needed to come up with a concept that would allow us to develop an idea. So the whole notion of the entire tower is about light. So there's 2 surfaces. There's an exterior surface of the tower, and then just set back from that external surface is another surface, which is about 8 inches back. So both of those surfaces are meant to capture qualities of light that are unique to Manhattan or New York qualities of light, downtown Manhattan. And the idea here is these are a company that we began to work with. Then they actually make mining equipment. They had never done an architectural project before, and water filtration systems. But we began to develop this system where there's a outer surface of these heavier stainless steel ribs, prisms, and then there's an inner surface of these prisms. And those panels would then be put up onto the building, and in the daytime, the daylight would interact with this outer surface, and you would get effects like that. And then at nighttime, it would interact with the inner surface. So in the daytime, you'd tend to see these other surfaces. This is the base of the building coming up, and some of the earlier panels going on the building. But you end up with this. I mean, you end up with a skin that works on the principle of your eye. Typically, when your eye looks at something, it looks at the brightest surface, and then your eye tends to stop at that surface, and it doesn't really challenge you to see beyond that surface. So in the daytime, you sort of see this surface, and by rotating the prisms slightly on the surface, it's basically just reflecting 2 slightly different views. There's nothing This is just about reflected light and then diffusing it slightly. So it's not a mirror, it's just slightly less than a mirror. So you get this sort of quality of light in the daytime. And then at nighttime, we're illuminating the inner surface of the screen. So inside, behind that outer surface are LED lights that illuminate that inner screen. So you see the nighttime view there. So the principle is simply the wall is 50% open. So if you walk up to this, you can look right through it. But by lighting the outer surface with daylight, you think that's the surface of the building. Lighting the inner surface, you think that's the building. And your eye never looks back to see the transformers behind it. So here you have a view of that on the outside, and it's linked up to a series of cameras that are activated by people, so the light actually sort of tracks the movement of people on the building, and that's the base of the building. So it's all about working with daylight. On the exterior of the building, it obviously has to deal with issues of blast. I mean, the transformers exploding, protecting the pedestrian so it doesn't come out in the street, so it has all those overlays to it. And then the main entry of the building, this is the first building to go up in downtown Manhattan, and it's actually, it is like, I think, the first LEED's silver building in the city. But being the first building after 9/11, there was an enormous amount of concern, as you might imagine, about, well, people are going to occupy big buildings again or not, or what do you do with a big building in the same location? Is there going to be a sense of whatever, fear about being in the building, and then is everybody going to want the buildings to be more closed and sense of security through use of more concrete or something? But the principle that we were working with here is how you provide the highest level of security, but nobody actually knows it. So you keep the buildings, they appear to be as open as possible and as daylit as possible and as welcoming as possible, but this whole wall system that's here and the entry, this is all designed for very, very high blasts, like truckload blasts. And you can see these are cable systems. The whole system is built on cables that allow for the force of an instantaneous explosion, that sort of wave of force that comes off it. The cables are allowed to move. The glass panels actually slip, and then on the return they come back into position. So the whole wall is built around absorption of energy rather than pure resistance of energy. And then you go into the building, and then there's a second wall. There's another wall that you'll see inside the building, which was a collaboration with an artist named Jenny Holzer, which has these techs, LED techs on the surface. And this, again, is actually another blast wall that protects the elevator core of the building. So this is, again, like where we get involved in something where it's obviously an aesthetic goal, but it's overlaid with many other levels of concern, whether it's energy issues or security issues, but you don't want people to recognize that as an overt sort of effort. It's just sort of put into the system. So that's the lobby part of the building that you'll see. And then that's the overall building. But the other principle or point I just wanted to make in this brief talk is that in working with light, and when you're building buildings in the city, large-scale buildings, you're obviously occupying a slice of a public resource. I mean, if you think of daylight as a public resource, buildings are constantly occupying that public resource. So how does the building sort of provide some return for that occupancy? And normally we always think about buildings for the occupant, like you've privatized a public resource. You have daylight. We all deal with daylight for the occupied space, improving that work environment. Of course, that's what we're trying to do. We're trying to make that a better environment for work. But simultaneously, there needs to be a reciprocal responsibility to provide light to the public and sort of engage the public with a richer sense of light on the exterior of the building. So the principle in this building was very large lights of clear glass that run floor to ceiling, and in fact, they go beyond the floor. This little detail that we developed where you're looking at a section of the building. This is what's referred to as the spandrel section of the building. This is the structure of the building where you have all your steel and some of your sprinklers and all of that. This would be the ceiling of one office floor. The glass comes right to the ceiling and starts down. That glass comes down. It goes right past the floor slab. It's sealed at the back of the floor slab, comes down, then overhangs the spandrel. And then we've curved this spandrel panel at the back slightly. So it's actually like a slight lens. And then at the base, what we've done is introduced a reflector. So conventionally, when you're looking up at a building, like this is looking at this spandrel section, it's like a slightly corrugated surface. And as you might imagine on a corrugation, the sunlight's obviously hitting the top, but what you're looking at from the street is actually the shadowed part of it. And this is like one of the phenomena, if you look at the New York Times building, it's one of the phenomena why it appears to be darker. It's actually, you're looking at the surface that's giving back to you the light from the ground rather than the light from the sun. But taking this idea of what's in the shadow of the corrugation, we actually introduce a reflector at the sill. The light comes down and it bounces back up. So we've actually put blue light back up into the shadow. And the rationale for that is that the blue light basically fills this whole daylighting reflector. And this is something you don't see on the building because it's outside and not visible from below. But there is this blue reflector that runs around every floor. And the principle is that the blue light, when you look at the building, basically merges with the blue of the sky around it. So what is the structure is given the same lighting level and quality of light with the sky around it. So it disappears oftentimes. And then the glass panels just look like they're floating down. So you get these cassettes of glass that come down. And then other times, depending on where you are, all of those daylighting reflectors just light up. So you have, in the upper part of the building, you have the outer glass layer, which is giving you some of this reflective quality here. And then you have this curved reflector, which is sort of the sky plane behind it. So you have that same dimension. And then as you come down to the base of the building, as I showed you a moment ago, that stainless steel prisms on the outside work with daylight, and the inner screen works with artificial light. So the whole building has a dimension to it that's all about light striking multiple surfaces. And therefore, the building becomes much richer. It's no longer just a monolithic surface, and it takes on a more positive sort of quality of light in the neighborhood. And then I'll just conclude quickly with this last project, which is thinking about light in a very different way, where you're working, say, in the Middle East, where you have enormous amount of light, of course, and then how you bring those light levels down to a reasonable level, both for the thermal performance of the building, certainly, but also just for your sensibility of your eye sort of adapting to it. So this is the reorganization and sort of redesign of the Israel Museum. It's in Jerusalem. And we worked on this for about the last 6 years. And it was just opened last year. But the original buildings were built in 1964. They're sort of concrete boxes that were done in 1964 with very small windows at the top of them. And we wanted to design buildings, these are the new buildings, which are totally made out of glass, all glass, not even insulated glass, just laminated clear glass, which sort of meant that you had to modify what light gets in the building or prevent any light from getting in the building. So this is the original campus, and we took out some roads and reorganized buildings and tore down some buildings and basically sort of reorganized the whole space over about 20 acres. And originally you'd have to walk in, go all the way up this hill, over into that building, then down, and then you arrive at the museum entry. And obviously there was no handicapped accessibility. So one of our major things was how to reintroduce a connection to nature. It's a very beautiful landscape. Get rid of the roads that ran through the center of the campus and the trash pickup and restaurant pickup. Build a series of new buildings at the entry, which are new restaurants and bookstore and ticketing. And then this whole below ground passage and the above ground passage. There's two routes going parallel to each other that enter into a new building here that leads to new exhibition spaces. So quite complicated in the sense of working within a fairly complex environment. Original buildings done by a fellow named Alfred Mansfeld, building by Frederick Kiesler that houses all the Dead Sea Scrolls, and this is a large Isamu Noguchi sculpture garden outside. So a lot of key pieces within the campus. And then our work was really how you would take this whole insertion into the campus and remove those roads and build this underground walkway. So the excavations up through the campus, and then superimposition of a drawing of the old walkway being put back down, water elements bringing light into the below ground space, and that's the new building being inserted. This is this walkway, and then how that gets transformed into this. That's basically the new passageway, which is below ground. And this, you're standing here, you're actually almost 20 meters below ground. So you're, say, for us, 60 feet below ground. How do you make that feel daylit? How do you get people that are that far below ground to feel like they're connected to the landscape and nature and the qualities of light? So we have these courtyards outside that bring in light, and they're all grown plant life, so you have a sense of greenery along here. And then there's a water element that runs along the whole walkway that allows sunlight to come through it and then animate that whole lower space. So little sections of that, new buildings and equipment coming up all the way up into the space. And that was that entry below ground. And then for the buildings themselves above ground, as I said, wanting to build buildings entirely out of just not even insulated glass, but just clear laminated glass. The buildings are all glass. We then framed them or housed them in these shading pavilions, and we developed two different configurations. One shading system for the east-west of the buildings, obviously where you get the low angle of sunrise and low angle of sunset, where you get the most heat coming into the building. One elevation for those two exposures, and then a different shading system for the north-south, which can be much more open. But the principle here is with these extrusions, which I'll show you, these are ceramic extrusions. As the sunlight comes down, and then it's designed in such a way that it has a slight curve inside, so the light hits on the outside, and then the light bounces back and then illuminates the inner surface. So the outer wall basically is we're actually sloped a little bit, taking the light and bouncing it back on itself. So when you're in the building, the whole, what you would think would be shadow or shaded, is actually all illuminated with very soft light. And then you have this phenomenon that happens, which is demonstrated here, is that even though you don't see what's outside, it's completely blocked, you don't have a direct vision, you can actually see the shape of trees and the color of trees and all of that sort of brought in. So it's again a way of trying to constantly engage people with landscape and qualities of nature around you, but just invent a way that first and foremost protects you from the intensity of the light, but still keeps you involved. So these are the north-south elevation, which you can obviously see through. That has sort of an unusual profile to it as well, which does the same thing. And then there's oftentimes shaded areas between the glazed areas. So there's shaded, cooler walking areas around the outsides of the buildings. And this is walking under a trellis area up into that below ground passage. And you're looking through the passage at the beginning, and it continues off to your left here, and you can see people walking on the old path up above there. So you got people walking at two different elevations. And when you're in that space, you sort of end up with this sort of quality of light. And the light is coming in because we have this water element overhead with light coming down. That's the diffused glass wall of the tunnel with these courtyards that are sort of intermittent along the walkway. So here it is, the glass. So this is a little bit, if you think back to that project at Hearst Building that I showed you before, which is here on Hudson, on 8th Avenue, that had those cast glass elements where we're running that chilled water over it. When we built that, we hadn't really thought of this, but if you go back in the mechanical room, which is where the pumps are and all that, you can actually look right through it. And we said, well, God, this is like pretty spectacular. You're sort of looking at all this water coming down, but nobody sees it except the maintenance people. So we actually sort of then designed this whole system so that if you're down below, you can look up. Actually, the water's running over the surface, the sun comes through the water, so that whole space is sort of animated by qualities of light. So these are the other spaces. You come out of that below ground passage up into these new spaces. That's sort of the quality of light on that completely shaded surface that you can see there. And just give you a little sense of some of these spaces. So I guess just this last slide. So just in summary, you know, as architects and designers, I think that we do a lot of work with, as I said, with Corning Glass Works, and we've done a lot of work with photovoltaics. We've done a lot of photovoltaic plants that are designed just for peak production, you know, in Texas and Arizona. Whenever they get those peak hours, they just are used only for 2 o'clock to 5 o'clock in the afternoon and come online. But I think that this opportunity that glass currently is sort of offering with these very, very thin glasses. There are ways of introducing much higher technologies into the glass as a thin film than there ever would have been on these thicker types of glasses. In the same way we use glass today and we apply coatings to it, like low-E coatings or highly reflective coatings or any type of instrumentation coatings to it, the glass is simply serving as a substrate. But with thin film glasses today, which I said are literally the thickness of the paper, you can actually introduce much higher technologies to it. For instance, one of the things we're working on right now is relative to healthcare issues is that you can include silver halide in the glass composition itself, and those types of chemicals basically kill bacteria and viruses. So you can actually produce a glass, a super thin film glass that would be bonded to like all surfaces and doors, everything. All these things can be made out of glass today and would prevent sort of the spread of bacteria and viruses. So there's huge opportunities for things as simple as that for these thin film glasses. But for architecture, similarly, you can introduce very sophisticated louvering systems, shading systems, electrochromic systems, other things that you would never have been able to afford to do previously. So there's a big transformation which will probably take another 10 years to actually happen, because there's no industry out there that can actually deal with these thin glasses. So it's a way, it's trying to establish like what type of industry is that can handle these new glasses. It's totally different than the current industry, and how you begin to introduce that and how that can contribute to both sort of power opportunities and daylighting opportunities, all these things that happen on buildings. So it's probably a little different than the other talks you've been hearing, but it might be of might have been of interest anyway.